These are the procedures to wire a circuit using a single pole, single throw switch and a single light bulb. After that circuit is tested, we will add in a second lamp. The second bulb can be connected to the first bulb in one of two different configurations, either in series, which means there is only one path for electrons or electricity to flow, or in parallel, which means the flow of electrons or current will split and go in two different directions when it reaches a junction point. The springs used on the circuit board will act as our junction. The springs on the boards allow us to connect additional wires without using tools. Keep in mind that one wire is already attached to the spring underneath the board. This is so we do not need to wire in the bulbs, resistors, and switches. The power supply is used in place of the battery. The red and black terminal post on the board are our positive and negative battery terminals. The terminals are inputs from the power supply. They are connected to the two springs in front of them marked positive and negative. The springs are the battery terminal outputs. The circuit breaker is wired under the board between the positive input and output to protect the circuit from shorts. It will be shown on schematic diagrams, but students do not need to wire it up. Before wiring any circuit, the first step is to adjust the power supply to the correct output. Before connecting the wires from the power supply to the circuit, turn on the power and adjust the output between 15 and 20 volts. Now you can attach the red wire from the power supply to the red terminal and the black wire from the power supply to the black terminal post. To check that power is available at the output terminals, use the DC voltmeter setting and turn the power supply on to measure the output. If there is no output, check for loose wires underneath the project board. Once adjusted, turn off the power supply and disconnect the terminal wires while wiring the circuit. Next, we are going to wire a switch and one light socket. Start at the positive battery terminal spring and run a wire to the SBSD switch identified as S1. These components are represented on schematic diagrams using symbols. The wire is also represented on the diagram using a vertical or horizontal lines. Connect a wire from the positive spring to one side of switch S1. The two springs to the right of the switch are connected to the connections on the back of the switch. Either connection can be used, but it is better to keep it neat and use just enough wire. Likewise, each light socket also has two springs. Electrons will flow in one side and out the other side. Using lamp number 3, connect a wire from the unused side of the switch to one of the lamp springs. The opposite side of the lamp will be connected directly to the negative battery terminal spring. Your circuit should be completely wired and ready to test. Check to make sure all wires are connected and switch S1 is in the off position. Next, hook the power supply back up and apply power. Check the circuit for proper operation by turning the switch on and off. Next, we will wire in a second light. Turn the power supply off when doing any wiring to the circuits. To wire the bulbs in series, remove the negative wire from the first lamp and attach it to the second lamp. Now each lamp has one wire attached to it and two unused spring connections. Connect another wire using each of the remaining spring connections. Look at the schematic diagram for this circuit and notice that electron flow can only take one path. This is the definition of a series circuit. Turn the power supply on and test the circuit using switch S1. Both lights will illuminate and go off together. If one bulb is unscrewed, neither light will work. It doesn't matter which bulb. This is similar to how some Christmas lights work. When wired in series, when one bulb goes out, they all go out. Remove the second light and put the single bulb back to its original configuration. To run a second lamp in parallel, run a wire from each lamp spring to each spring of the second bulb. Again, reconnect the power supply and apply power to the circuit. The switch will turn on and off both lamps as before, but the bulbs will be brighter. The electron flow or current is split into two different paths. Loosening the bulb in one path does not affect the other path. If one bulb goes out, the other bulbs remain on. This is how your house is wired. This video demonstrates a simple series and parallel circuit. The project booklet with this training board goes into more depth and more complex circuits. For more information, contact Aviation Training Foundation.